Get low when the whistle go. Get low when the whistle go.
What is a deadlock? In an operation system, a situation when a process or thread enters a waiting state because a request system resource is held by another waiting process, which in turn is waiting for another resource held by another waiting process. For an example, in an operation system, these pointed areas are the resources shared by the processes which are represented by this car. Another example, two computers request to use printer at the same time, so we call it deadlock.
The mutual exclusion is the resources involved are non-shareable. At least one resource must be held in a non-shareable mode, that is only one process at a time claims exclusive control of the resource. If another process requests that resource, the requesting process must be delayed until the resource has been released. For example, at a railway crossing, either the train or the other vehicles can pass at a time. This is an example of mutual exclusion condition.
The second one is no preemption. No preemption, a resource cannot forcibly be taken away from a process. It has to voluntarily release the resources it is holding. In other words, resources cannot be preempted. The non-preemption condition can be alleviated by forcing a process waiting for a resource that cannot immediately be allocated to release all of its currently held resources, so that other processes may use them to finish. Suppose a process holds resources a second process may need in order to proceed, while second process may hold the resources needed by the first process. This is a deadlock. This strategy requires that when a process that is holding some resources is denied a request for additional resources, the process must release its whole resources and, if it necessary, request them again together with additional resources. Implementation of this strategy denies the no-preemptive condition effective.
Next, hold and wait. There must be a process holding one resource and waiting for another. The hold and wait condition states the process is holding onto a resource that may or not may be required by other process. The key point here is that the resource is holding onto those resources and will not release them until it gets access to the requested resource.
Circle wait condition. The circle wait condition is a set of processes that waiting for each other in circle form. Each process must be waiting for resources which is being held by another process, which in turn is waiting for the first process to release the resources. This is this example.
Deadlock prevention. Deadlock can be prevented by preventing at least one of the four required conditions. First, mutual exclusion. Second, hold and wait. Third, no preemption. Fourth, circular wait.
Deadlock avoidance. It recommends that the system has some additional of a priority information available. Simple and most useful model requires that each process declare the maximum number of resources of each type that it may need. The deadlock avoidance algorithm dynamically examines the resources allocation state to ensure that there can never be a circular wait condition.
The law deduct. System-Deadlock is when we allow the system to enter into deadlock state. Deadlock detection. If the resources have a single instance, in this case for deadlock detection, we can run an algorithm to check for cycle in the resources allocation graph. Presence of cycle in the graph is sufficient condition for deadlock. For example, if there is a circle R1 to P1, P1 to R2, R2 to P2. R1 and R2 have a single instance, so the deadlock is confirmed. If there are multiple instances, detection of the cycle is necessary, but not sufficient condition for deadlock detection. In this case, the system may or may not be in deadlock varies according to different situations.
Two recovery methods, which is first, killing of the process. Killing of the process involved in the deadlock. Killing process one by one. After killing each process, check for deadlock again. Keep repeating the process, the system recovers from deadlock. Second, resource preemption. Resources are preempted from the process involved in the deadlock. Preempted resources are allocated to other processes so that there is a possibility of recovering the system from deadlock. In this case, the system goes into starvation.
Methods for handling deadlock is ignore deadlock. Deadlock ignorance, also known as ostrich algorithm. Deadlock will occur when more processes trying to requesting the same resources. Ignorance of deadlock will done by mostly used operating system like Windows and Linux. Actually, the deadlock will occur rarely. So, whenever it occurs, the operating system will hang. We have to just restart the system. Whenever we restart the system, the problem will be retried. Thus, we call it as a deadlock ignorance. Try to ignore the deadlock by simply restarting the system. It is the deadlock ignorance. Try to ignore the deadlock by simply restarting the system.
Thanks for watching.
Get low when the whistle go.